Our next topic is about roots. So we want to start out with just a basic definition. The principal nth root is the root that has the same sign as a. So we'll get back to that in just a minute, but some basic vocabulary. This, of course, is a radical sign. The number that's underneath it is called the radicand. I don't use that word that often, but that is what it's called. And this is a pretty important one, the index. The index tells you if you're taking the square root, the cube root, the fourth root, and so on. Now, something we need to talk about briefly is when we were in, Algebra 1 and Algebra 2, we had problems like this. X squared is 4. So we're trying to solve for x, so we take the square root of both sides. And remember, we don't know which root we want, okay? Since we introduced the square root, we have to say, I don't know if they wanted the plus or the minus root. So our answer was plus or minus 2. Because, of course, remember our original problem, x squared equals 4. 2 squared is 4, and negative 2 squared is also 4. So we had two answers. So that's what we did when you introduced the radical sign. Now, if you are given the radical sign, like this one, the square root of 4, we want the answer that's the same sign as the radicand. Okay, so since the 4 is positive, we want the answer of positive 2. The square root of 4 is not negative 2. Okay, if you are given the square root of 4, that's the problem. You need to give the sign that's the same as the radicand as the 4. Now, if I want to know the negative root, I have to say that. Look, right here. I want the negative square root of 4. And you know that, well, obviously the square root of 4 is 2, but said, oh, we want the negative root, so negative 2. So I hope that makes sense. We'll be dealing with that a lot. So we want to evaluate these if possible. So exactly what we were just talking about, 8a, we want the negative square root of 144. So of course the square root of 144 is 12, and we want the negative root, so negative 12. In b, we want the square root of negative 144, and if you remember back to Algebra 1, we cannot take the square root of a negative, well, unless we have imaginary numbers. But we're not dealing with those right now, not yet. So for this one, we're going to say no real solution. If your index is even, and this is a square root, so it's 2, if you have an even index, you cannot do an even index of a negative. If you have an odd index, you can. We'll deal with that later. Okay, C, fractions. For some reason, people get very scared about these. These are easy. If you have the square root of fraction, just take the square root of the top and the square root of the bottom. So we get 5/8. Likewise, in D, in part D, we want the negative root, so our answer is going to be negative, but we're just going to take the cube root of the top and the cube root of the bottom. So again, our answer is negative. The cube root of 8 is 2, and the cube root of 27 is 3. So negative 2/3. All right, to do these problems, you need to know your perfect squares and perfect cubes. So you should recognize these. 1, 4, 9. The next perfect square is 16, 25, 36. I expect that you know those and you recognize them. Cubes you should also start to recognize. 1, 8, 27, 64, 125, 216. I mean, these are a little harder. We're not quite as familiar with them, but you should start recognizing these things. So in the next section, I have listed all of our properties of radicals. So like in number 1, if you have the nth root of a to the m, you can pull that m out of the radical. And it's the nth root of a to the nth power. You're allowed to, if they have the same index, you can multiply two things that are under the radical. With fractions, you can split them. If you're taking the root of a root, you can multiply the indexes. And if you're doing the nth root, and this is number 5, if you're doing the nth root to the nth power, the nth root and the nth power will cancel each other out. So it's a if n is odd, and then the absolute value of a if n is even. So there are more examples of these on page 19. I know that was a very quick run through of that. But we want to use these properties to simplify here in number 9. So, for example, 125. Now we know that the square root of 125 is not, that's not a perfect square. But you might be able to recognize 125. 125 is the same thing as 25 times 5. And because of the properties of radicals, I can split this up. This is the same thing as the square root of 25 times the square root of 5 over the square root of 5. Now notice we have a square root of 5 and a square root of 5, top and bottom. Those will cancel. And we're just left with the square root of 25, which of course is 5, is our final answer. Okay, in B, we have the cube root of 125 squared. Now, I do not want to do 125 squared. I don't know where I put my calculator. That's a very large number. So I'm going to use that first property that we talked about, and I'm going to scoot that square root out. So this is the cube root of 125 squared. This is the same thing. Now, hopefully you recognize 125 is a cube root. The cube root of 125 is 5. So now I have 5 squared, which is 25. Way easier than taking 125 squared at the beginning of the problem. Okay, in part C, these are both cube roots, so we are allowed to multiply the things under the radicals. Okay, so I can say this is the same thing as the cube root of x squared times x to the first. I'm going to add those exponents, so we have x cubed. And then using the fifth property that we talked about, the cube root and the cube, those are going to cancel each other out. So we just get x. Okay? And since it's an odd index, it is x. We don't have to worry about absolute value. All right, D, these are both square roots. We're doing the square root of the square root of x. So we don't usually write the index, but these are both square roots, like this. So we are actually allowed to multiply those indices. Indices, I don't even know how you say that. So 2 times 2, this is the same thing as the fourth root of x. Okay? And there's nothing else we can do with that, so we'll just leave it at that. In the next clip, we'll talk about how to use these properties to simplify and do some more operations.